We're about to dive into a piece of tech that could completely change how we all interact with AI. I mean, imagine taking the raw power of a giant data center and putting it right into the device you're holding in your hand. That's the revolution we're talking about today. Seriously, just think about that for a second. What if you could run a huge, 27 billion parameter model, and I don't mean some watered-down compressed version, I mean the full-strength thing, on your phone? It sounds like pure science fiction, right? But what's so incredible is that we are getting closer to this becoming a reality every single day. And here's the first mind-blowing number. We're talking about a brand new kind of AI model that is 14 times smaller in file size than the traditional ones. It's the same intelligence, the same number of parameters, just crammed into a radically smaller package. But, the file size is really only half the story. The real game changer here is memory. Because it's so much smaller, it needs about 15 times less RAM to actually run. And this is the breakthrough. This is what unlocks the ability to run these unbelievably powerful models on just regular consumer hardware, not some supercomputer in a lab. So this technology that makes it all possible is called a one-bit model. And its promise is simple, really, to get the most AI intelligence possible using the absolute minimum amount of energy and digital space. Think of it like this. A normal model is like a super high-res photo with millions of color values for every single pixel. A one-bit model is like a masterful black and white sketch. It's just so cleverly drawn that it captures the exact same idea, but with a tiny fraction of the data. For the longest time, though, that's all it was, just a promise. A really fascinating idea on paper, but in the real world, it was a huge, unproven risk. Nobody was sure if it could actually work at a large scale without, losing the very intelligence it was trying to preserve. And the theory itself isn't exactly brand new. The original research paper, which was called BitNet, came out back in 2023. But then, for about 2 years, it just sat there. The idea was brilliant, but the sheer cost and risk of building a real model from scratch just kept it on the shelf. Until now. Okay, and this brings us to a really big misconception. A one-bit model isn't just a normal AI that's been squished down. Nope, it's an entirely new architecture. You have to design them and train them from the ground up, which is an incredibly difficult and expensive process. This quote really hits the nail on the head. I mean, can you imagine spending hundreds of thousands of dollars to train a completely new type of model, only for it to completely fail? That massive financial risk is exactly why, for 2 whole years, nobody was willing to take the plunge. Yeah, the few early attempts that people did try were, well, they were not good. They were trained on tiny, tiny data sets, and they produced all these bizarre errors. For example, one model, when you gave it a document with the name Anything LLM, would just spit back a misspelled mess. They were completely unusable for any real project. But this is where the story takes a really exciting turn. A startup called Prism ML finally cracked the code. They produced the first ever commercially viable one-bit models. And this was the moment that the theory finally became a reality. They called their models Bonsai, which is just a perfect name, right? Something so small, yet so powerful. Now, I should mention, these are proprietary models, so they're not open source, but they represent a monumental leap forward. They proved that the whole one-bit promise was actually achievable. And the numbers here, they're just staggering. A standard 8 billion parameter model is over 16 gigabytes, and it needs about that much RAM to run. The Bonsai one-bit version of the exact same model, it's just over 1 gigabyte. 1. That's the entire model. When you see it visually, the difference is just insane. I mean, we're going from needing a high-end machine packed with RAM to something that a basic laptop or even a phone could handle with ease. The resource requirement just plummets. It's crazy. So why does this matter so much? Well, before, the model itself would eat up almost all of your available memory. That left very little room for your actual conversation or the document you were working on. But now, the model is tiny, and that frees up a massive amount of space for a huge context window. It means you can have much longer, much more complex conversations. Okay, so the specs on paper are really impressive, for sure. But what can this thing actually do? Let's take a look at how it performs in a real-world test. So the very first thing you noticed is the speed. On just a standard MacBook, the model was hitting around 130 tokens per second. That's incredibly fast. And it proves that this new efficiency doesn't sacrifice performance at all. It's both small and quick. The demo results were just wild. It took a web article and turned it into a multi-page PDF. It pulled images and tables directly from the website and formatted them correctly. It even handled complex tasks that require multiple steps, which is something even bigger models can struggle with. But the ultimate test was this: turning a dense, technical blog post into a pitch deck. Now, to do this, the model had to spawn multiple sub-agents. You can think of them as little copies of itself, to go research each section of the presentation on their own before putting it all together. I mean, that is a truly complex reasoning task. And it worked perfectly. The person who was running the demo, someone who works with these models every single day, was left genuinely speechless. This wasn't just a small step forward. It was a shocking leap in what local AI can do. So what does this all mean for us? It means the future of powerful AI is local. It's on your machine, not in some server farm thousands of miles away. This is the fundamental shift. For years, the true state-of-the-art AI was pretty much the exclusive playground of big tech companies with endless cloud computing resources. Now, that same power is becoming accessible to pretty much anyone with a modern laptop. And honestly, we're just getting started here. The next step is to combine this one-bit architecture with other compression technologies to make it even more efficient. And of course, the big question on everyone's mind is, can we scale this thing up? The community is already buzzing about a 27 billion parameter one-bit model. Let's just pause on that for a second. All of this, the complex research, the document creation, the multi-agent reasoning, was done by a foundational AI model, running completely locally on a laptop. These are tasks that were just flat out unthinkable a short time ago. And that really brings us to the final thought. An 8 billion parameter model was able to do all of that. So the big question we're left with is, what happens next? What becomes possible when this technology scales to 27 billion parameters or even bigger, and runs on the device that's in your pocket right now? The possibilities they're truly mind-blowing.